Here is our first attempt to talk about disorders of hemostasis. This is pertaining to platelets alone. Now, first thing we would do is to look at the coagulation cascade. Then we would organize the disorders into which factors are affected at which phase and what would that lead to, etc. So in order to do that, let's review the coagulation cascade right away. So initially, it is injury to the blood vessel that releases tissue factor. Okay, injury to the blood vessel wall, subendothelial cell releasing tissue factor would now target factor 7. The diamond shape typically represents an inactive form of factor 7, which is now activated to its activated state in the presence of tissue factor, and circle represents the activated state. All right, so now the two together, that is factor 7 and tissue factor, presence of calcium, would target factor 10. Factor 10 that was in its inactive state is now activated in the presence of this complex, that is factor 7a, a tissue factor, some calcium. So activation of factor 10 would lead to the common pathway. But here, first thing that you see is a small amount of factor 10 being activated, which then activates prothrombin with the help of factor 5. Again, this is a cofactor. Cofactor is shown in a square. Inactive state to its active state. Factor 5a forms a complex with factor 10a, and then together with some calcium, they would target inactive enzyme prothrombin and now catalyze it to thrombin. Thrombin is now going to target fibrinogen and convert it into fibrin. So this is the initiation phase. This is how it all gets started. Okay, please note it's all occurring rather at a small level. Okay, so only like about 5% of the activation is seen in the initiation phase. Interesting thing is that thrombin has a positive feedback effect. It targets platelets, activates platelets. When it activates platelets, platelets release factor 5, and therefore, so you are going to activate more factor 10. More factor 10 means more thrombin production, more fibrinogen to fibrin reaction. So this is what you call as amplification phase, the second phase. Now, the third one is the propagation phase. What you expect here is the involvement of the intrinsic pathway, right? Activated thrombin would have not only its positive feedback effect on platelets, but it would also activate factor 9 to its active state and factor 8 to its active state. So factor 9 is part of the intrinsic pathway, and factor 8 is a cofactor. So all of these are part of the intrinsic pathway now being turned on. The activation of factor 10 is going to be in much greater amounts than before. Okay, initially it was only a smaller percentage of factor 10 activation, But with this positive feedback effect from thrombin, the activation of factor 10 in much greater amounts is what is going to cause the clotting at a much greater speed. So that is what we want to take from this slide. And the same thing is shown in much more clearer form here. This is our initiation phase. What did we say about the initiation phase? Tissue factor activating factor 7, and then factor 7 and tissue factor together are able to activate factor 10 to its active state, along with factor 5 in the activated state. This complex, along with calcium, would convert factor 2, this is prothrombin, to its active state thrombin. Okay, and here what you're seeing is tissue factor and factor 7A. There is a small amount of factor 9 being activated to factor 9A. So this is a smaller amount. This is going to become much more quicker later on. Here is the amplification phase, where you're talking about the involvement of platelet activation. So you understand this part already. That is tissue factor along with factor 7. Along with factor 7, you have activated factor 10 along with 5, activating the factor 2, that is prothrombin to thrombin. Thrombin activating a platelet, releasing more factor 5, and now it's going to initiate the activation of cofactor factor 8, that's VWF, and then so that is one thing that's going on. And also note here, thrombin. Thrombin has this positive feedback effect. It's going to activate factor 11 to 11A. All right, so factor 11A would turn on the next phase, that would be the propagation phase. So activation of the platelet, you notice the change in shape. All right, you have factor 11A, factor 8A, factor 5A, and now this is where the intrinsic pathway is activated, activation of platelet. So this is when a much greater results of coagulation can be seen. All right, so let's